Okay, so the notes that we are going to take today are actually not going to be in your chem journal. You're just going to write it straight on 13.5. So if you don't have the worksheet printed or you can't find it, go ahead and press pause on the video and find it, and then you can start the notes. So all of the problems on the worksheet are going to be using Pivner. So at the top, let's go ahead and write PV equals nRT. Then I'm also going to write the R. R is always 0.0821, and the units are liters times ATM all over moles times Kelvin. Now, there are these little boxes here, and these guys, they're the answers, except for number 1, because that's the wrong answer. But that's just the answer. So don't let those confuse you. I just went ahead and let you know ahead of time what your answers should be. So, number 1. Now, looking at number 1, the main difference with these problems is that they give you a balanced equation, and that is your little hint that there's going to be something a little bit different about these problems. But the different thing doesn't really come until the end. So I'm just going to go ahead and write down what I have. So it says how many moles of carbon dioxide? So that's going to be N. So N equals, I don't know, of carbon dioxide. So this is what's a little bit different. I'm being specific as to what compound they want. They want moles of carbon dioxide are made when 12.4 liters, so there's volume. So V equals 12.4 liters of oxygen gas, and oxygen gas, remember, is O2, liters of O2. Once again, notice how I'm being specific about what compound it is. They wanted moles of carbon dioxide. They gave me liters of oxygen. I know I need to be specific when they give me a balanced equation. Reacts at a temperature of 298 Kelvin, so temperature equals 298 Kelvin, and it reacts at a pressure of 3.4 atmospheres. So pressure equals 3.4 atm. So this is Pivner, so I'm going to go ahead and write PV equals nRT. Now before I plug anything in, I'm going to double check my units. Liters, liters, Kelvin, Kelvin, ATM, ATM. So I'm good to go. I can plug everything in, so I'm going to go ahead and do that. So pressure is 3.4. Volume is 12.4. I'm trying to solve for N. R is always 0.0821. And temperature is 298. So I'm going to solve for N. So I divide each side by 0.0821 and 298. 0.0821 and 298. Now, when I type that into my calculator, I get N equals 1.723 N's in moles. Now, here's what's a little bit different. I need to be specific as to what moles I have. Now, I plugged in liters of oxygen, 12.4 liters of oxygen. That means I spit out moles of oxygen. Okay? So whatever volume I plug in, whatever compound that is, I plugged in liters of oxygen. That means I'm going to get out moles of whatever that compound is. So I'm going to write ourselves a little note, and I'm going to say I plugged in liters of O2, so I, quote, spit out moles of O2. Whatever compound you plug into PivNert, that's the compound you're going to get out. So now I look back and I see, well, they didn't want moles of oxygen. They wanted moles of carbon dioxide. So all I need to do at this point is just make a very quick switcheroo using the balanced equation. I can use the balanced equation to go from O2, from moles of oxygen, to moles of carbon dioxide. So I'm going to take this number, 1.723 moles of oxygen, and I'm going to convert moles of oxygen to moles of carbon dioxide. So moles of O2 goes on bottom, moles of CO2 goes on top. For every 13 moles of oxygen, there are 8 moles of carbon dioxide. Moles of oxygen cancel, they go and my calculator is going to spit out 1.0604. Now I need to look at sig figs. 3 sig figs, 3 sig figs, 3 sig figs. So my answer should have 3 sig figs. So my final answer is 1.06 moles of CO2. Okay, I'm going to run that down very quickly one more time. I see a balanced equation. Hint that I need to be specific. They want moles of CO2. They gave me liters of oxygen. Plugged everything in. I found out the mole value. Since I plugged in liters of oxygen, I spit out moles of oxygen. They didn't want moles of oxygen. They wanted moles of carbon dioxide. So then I just make a quick switcheroo using the balanced equation. For every 13 moles of oxygen, there's 8 moles of carbon dioxide, and I get my number. Okay, so I'm going to go ahead and I'm going to do B now for you. So for B, it says how many grams of water. So they want grams of water, which is that's basically N. Okay, so N equals, I don't know, but they want it of water. They want grams of water. Are made when 5.66 liters of C4H10, so that's volume. Volume equals 5.66 liters of C4H10 reacts at a pressure of 1.22 atm. So pressure equals 1.22 atm and a temperature of 304 Kelvin. So temperature equals 304 Kelvin. So before I go and plug anything in to PivNert, I'm going to make sure my units work. Liters, liters, atm, atm, Kelvin, Kelvin. So I can go ahead and plug everything into PivNert. So I've got my formula, PV equals nRT. And notice they gave me liters of C4H10, and they want me to go to grams of water. The first thing I'm going to do is I am going to find moles first. First I'm going to find moles, and then I can do some converting. So I'm going to plug in chug right now. So pressure is 1.22. Volume is 5.66. I'm solving for N. I can't solve for grams right away, but I can solve for moles. R is always 0.0821, and temperature is 304. So I'm going to solve for N. It's a different color. So I'm going to divide each side by 0.0821 and 304. I'm going to go ahead and show you typing this into my calculator. 1.22 times 5.66, hit divided by 0.0821, hit divided by again, 304. So this is what my calculator gives me. My calculator gives me N equals 0.2766 moles. Now, I plugged in liters of C4H10. That means I spit out moles of C4H10. Okay? Whatever value of volume I plug in, I plugged in liters of C4H10, so I spit out moles of C4H10. Now I look back. They wanted grams of water. So now this is just kind of a stoichiometry problem. Basically, you can think of it as taking 0.2766 moles of C4H10 to grams of water. Okay, we're just going to island hop. So, just going to go ahead and kind of piggyback on this guy. I'm going to go from moles of C4H10 to moles of water. So I want to get rid of moles of C4H10 and go to moles of water. So for every 2 moles of C4H10, there are 10 moles of water. So moles of C4H10 cancel out. They go. So now I made the switcheroo from C4H10 to H2O, but they wanted grams of water. So now I'm just going to set up another conversion and go to grams of water. Moles of water go on bottom to cancel. Grams of water go on top. Moles gets a 1. Grams gets an 18.0148. Moles cancels out. Type that into my trusty calculator. 0.2766 times 10 times 18.0148 divided by 2. Notice our answers. So, calculator spits out 24.9144. Let's look at sig figs. 3 sig figs, 3 sig figs, 3 sig figs, 3 sig figs. So the final answer is 24.9 grams of H2O. Okay, so why don't you go ahead, and I'm going to check this on Monday, try C. Okay, notice they give you liters of carbon dioxide, but they want grams of O2. You're going to use the balanced equation to make your switcheroo, and this is your answer. Good luck.